Hi, hello everyone. First of all, thanks for being here in my YouTube channel. Let's discuss Model 5B 3-phase induction motor. The name itself indicates a motor which converts electrical to mechanical. 3-phase supply we are giving into the motor, and working principle is electromagnetic induction. That's why the name it is called as 3-phase induction motor. And another one special name will be there, rotating transformer. Similarity will be there, principle of transformer as well as induction motor principle. See here, transformer, primary this one, secondary this one. So supply we are giving primary side, induces EMF in the secondary side due to mutual flux linkage, right? So output this one. Similarly, stator is primary, this part is primary, rotor is secondary. There is no electrical connection between stator and rotor, only magnetically coupling. Due to three-phase supply, the rotor start rotating due to rotating magnetic field in the stator, right? Let's see working principle and construction of three-phase induction motor. Before getting into the topic, we'll see application where exactly we are using these three-phase induction motor for better understanding. See here, for lifting of water in our home also we are using three-phase induction motor as well as single-phase induction motor, right? And also in the electrical car, at present Tesla car where they are using three-phase induction motor instead of brushless DC motor. They are concentrating three-phase induction motor because of efficiency is high in the three-phase induction motor. This is all the parts. This is a stator, and then this is a rotor, and this is an end cover. Okay, inside there is a bearing is present, a shaft will be there, and then slats will be there. So we'll discuss one by one now. We'll see working principle of three-phase induction motor. The name itself indicates it works on the principle of Faraday's laws of electromagnetic induction, right? See, these are the parts of three-phase induction motor. Stator, stationary part. Rotor is a rotating part of the machine. Stator is having stator slats to holding field winding because we want rotating magnetic field. Just I'll be giving three-phase supply to the stator. What happens? It produces a circular magnetic field inside the stator, right? If suppose if you insert this rotor into the this periphery, what happens? This rotor cuts the rotating magnetic field, induces a current. So if suppose conductor induces a current, it is placed in the rotating magnetic field. What happens? Experience a force. So conductor starts rotating, right? Let's see working principle in detail. There is a rotating magnetic field from the stator. This is a stator, okay? So just consider this is a stator. And this one is a rotor. Okay, this is rotor. So rotation like this. Okay, and supply we are not giving, figure 1, and then figure 2. Let's see one by one diagram. The first diagram, supply we are not giving into the stator, right? There is no rotating magnetic field. This one is a stator, this one is a rotor. Rotor bar conductors are present. Next diagram, supply we have given. It produces a rotating magnetic field in the stator like this, okay? And conductor in the rotor is stationary, right? So second one, supply we have given. It produces rotating magnetic field. Continuously it is rotating in the speed of ns is equal to 120 f by p, right? See, this conductor, this bar conductor cuts by this magnetic field. What happens? Induces current, right? See, according to Faraday's laws of electromagnetic induction, when a current carrying conductor placed in a magnetic field, what happens? You experience a force like this. Force will be exerted, right? So it's like a stretching of rubber, high flux density to low flux density. So it start rotating in this same direction. If suppose rotating magnetic field in this direction, same direction it will rotate. Okay. So this is a principle of three-phase induction motor. First one is supply we are not given. Supply we have given. There is a rotating magnetic field is present, and rotating magnetic field cuts by this rotor bar conductor. What happens? Induces a current. So according to Faraday's laws of electromagnetic induction, so conductor carries a current, experience a force in the magnetic field. So conductor start rotating. That's all. This is the working principle. Just you write in your own theory. Don't buy at the concept. Let's see construction of three-phase induction motor. This is a stator. This is a rotor. I'll cut into half and then I'll draw sectional view. These are the parts of three-phase induction motor. I'll draw a cutout section. Okay. This is a yoke, and here there is a rotor and a rotor bar conductors. This one is a squirrel cage rotor, just to consider, and then this one is a shaft. Okay, So I'll draw. We'll mention the parts. This is a yoke and stator slats, and on stator field winding. This is rotor bar conductor or armature conductor. Okay, this one is shaft. Right. So we'll explain one by one. This is a stator part. This part. So stator is having a yoke, stator slats, and stator field winding. Right. And then rotor bar conductor and shaft. Okay, we'll explain stator and rotor now. So this part is this one, okay, and then this part is this one, okay. Stator is the stationary part of the machine, rotor is the rotating part of the machine. Yoke is the outer cover of the machine or frame for the machine, and also it avoids entering of dust particles, moisture contents inside the machine, and also it provides mechanical support to this stator slots. Next, there is a stator slots to holding the stator field winding. Next, there is a field winding to produce circular magnetic field. If suppose if you give power supply to the field winding, I mean the stator conductor, what happens? Produces circular magnetic field in the speed of ns is equal to 120 f by p. Okay. And next there is a rotor. Rotor is a rotating part of the machine. So there is a bar conductor. When bar conductor cuts this rotating magnetic field, what happens? Induces current. So if suppose conductor carries a current in the magnetic field, what happens? Experience a force. Next there is a shaft to holding the overall rotor. This base is for mounting purpose. Let's see how exactly three-phase induction motor will work. Three-phase supply voltage we are giving. Due to voltage, current will flow through the winding, that is IR, IY, IB. Due to current, what happens in the coil? Produces magnetic field, right? That magnetic field rotates at a speed of ns equal to 120 f by p. That's why it is called as a rotating magnetic field like this. It rotates. See, when conductor, this bar conductor cuts by this rotating magnetic field, what happens? Induces a current. See here, induces current. So what happens according to Faraday's laws of automatic induction? When a current carrying conductor placed in a magnetic field, you experience a force. It starts rotating in the same direction. That's a working of three-phase induction motor. Let's see types of rotor. We have two types. One is a squirrel cage type rotor. Another one is slip ring or phase wound rotor. It looks like a cage-like structure. That's why it is called as a squirrel cage. It is having a slip rings. That's why it is called as a slip ring rotor. And here resistance are absent, and here resistance are present, right? And speed control is not possible because there is no resistance. What is the use of resistance over here? To control the speed, right? But here absent. Speed control absent. But speed control is possible. This induction motor 90% application in the industry. 90% we are using squirrel cage rotor because there is no losses, there is no resistance, so losses will be less. So here only 10% we are using industry applications. Okay, just to consider this one is a rotor, okay, not a stator. We have to give a stator input like this. RYB supply we have to give, then only this rotor rotates, right? And here there is a bar like a skewed bars. Skewed bars are absent, right? Skewed bars. Here present, absent. Skewed bars. Why they made skewed bars here? If suppose straight will be there, means rotor slats and then stator slats collide each other. I mean interlock each other. What happens? It will jam. Okay, it will not rotate. That's why it's a skewed bars to eliminate harmonics. Right, like this structure. This is a squirrel cage rotor. Okay, this one is a stator. Just to consider. If you give power supply, then the rotor start rotating due to rotating magnetic field. Right, easy construction, but complicated this one. Okay, and then cost is less. Cost is high. And these motors we are using blowers, fan, and drilling machine, milling machine, etc. But this one is a heavy load application, lift, cranes, hoists, okay, elevators. Welded bars are present, welded in the end rings, but here there is no welded bars. We can add resistance. Here there is no adding of resistance. Okay, not possible.